Hello and welcome to this session at SUSECON Digital 2021 around edge computing and real-time analytics. And it really is that subtitle about it's residing as neighbors next where the data exists. So welcome again. This is Brian Gartner. I'm a senior technology strategist at SUSE. I work on our alliances team and I work with a lot of our alliance partners that are in the hardware space, the embedded space, the software space. And once you talk about edge ecosystem, you realize that it is very partner-centric. So the later example that we'll talk about talks about all of the partners that are involved to do something like this. And with that, I'm going to also let my peer, Brian Frome, introduce himself and go over the first section. Thank you.
Thanks, Brian. My name is Brian Frome. I'm a Technical Alliance Manager here at SUSE. And this is what we'll be covering today. Let's jump right in. So, edge applications are challenging for an enterprise because they bring new technologies that are probably foreign for many enterprises. If you think about what an enterprise does well today, in the past decade plus, they've built lots of web sites, right, that customers interact with, maybe even phone applications, so that the customer experience with the enterprise today is through a website or a phone interface to the same website. And the technologies in that stack, while not simple by any means, are confined to a stack of web technologies that are typically located in a data center or in a cloud location. So those technologies are very different from the technologies that are needed and the expertise that are needed to deal with an application at the edge. And that's because the edge introduces cameras and sensors and point of sales devices and kiosks and even the customer's phone. And all of those pieces have perhaps different programming environments. There's device programming to manage the sensor or the camera. There's phone programming, which is done in its own languages and is sort of tailored to a phone experience, typically very cloud-oriented. There's distributed computing architecture that's required to manage the edge application, because there are all these different pieces of the application that are separate from each other. And so an architecture has to be defined that's very heterogeneous, and devices can come and go from that environment. So you can see the description of what I'm talking about is very different and has a much wider range of technology stacks and programming environments than in the web application world. And so if you look at that, the expertise that many enterprises have are not tailored to the edge. So again, the edge presents these new challenges for a company to deal with. Then furthermore, the edge presents a wonderful opportunity in that it has a wealth of data, right? So these cameras and sensors and devices all bring their set of data with them. And that's a wonderful opportunity to apply machine learning and deep learning and big data analysis to this data to bring all sorts of new knowledge and capability to our customers. So that's why we are interested in the edge as an enterprise, because not only do we want to create a service, but we want to create an innovative and unique service to our customers that this data can really give us. So those are some of the challenges of what an enterprise has to wrestle with then when they look at an edge environment. So here today, we're going to focus in on healthcare, and specifically we'll be looking at an X-ray device. So this device, much like we've just talked about, introduces a whole set of new componentry. There's the X-ray device itself, which has custom boards and componentry that needs to be managed as part of the application. There's machine sensors, right, across the entire machine, or even what the machine plugs into, and other sensors maybe in the hospital environment that are part of the actual application that delivers the service. Then there's the hospital environment itself. There's where do we store the data, right? There's local data on the device, but the device can't store every single scan for its lifetime. It needs to offload those scans into the hospital environment. So the application environment needs to be aware of of those other capabilities. Where can it store things, and how does it move things around, and what about the network that it lives on? So those are all aspects of the application environment that are important as part of the program that we actually create. So again, this requires a distributed architecture that is new for many enterprises to implement. And so we'll dive into more about what the X-ray environment looks like, and how we manage that environment from an infrastructure standpoint, and talk a little bit about other technologies there, like machine learning and deep learning, that really bring us some of the key aspects to the service that we want. In particular, at an X-ray, not only do we want to get the X-ray data, but we want to look at it as quickly and as intelligently as possible before a radiologist even sees it, right? Maybe the device can actually trigger information that leads to more need for other kinds of scans. So an operator could just be alerted that, hey, you need to take these other scans right now. And that would be machine learning doing that work, again, so that a radiologist hasn't even seen the scan yet. So with that, let's switch into a use case description and more of a deep dive. And I'm going to pass it back to Brian.
Thank you, Brian, for setting this up and giving us the overview of what this is about. What I'd like to talk about is I'm going to drill through and show you how this is done from edge to core to cloud in a healthcare use case, again, that spanned many, many partners to make this happen, and also the incredible advances in technology that we've had that makes all of this possible. And it closes the loop and makes it so that patients benefit from this, along with all the other roles. Okay, so let's get started. We'll talk about 4 different roles here. First is the patient, who's obviously the person that's impacted by this the most, and also the benefactor of it. An X-ray technician who does certain things at the very, very edge, the far edge. A radiologist who does things and relies on stuff that was gathered at the far edge, but can be done at the near edge too, to do even further things. And then there's also a research data scientist in the medical field and stuff who can elaborate and help us iterate and improve it and go forward faster. So let's begin the scenario and talk about the patient who may have a hard time breathing. And this is where the scenario starts and how they benefit. And they just reach out to the medical profession to help them resolve that. Okay, let's begin the scenario. Let's say the patient has described their symptoms to the nurse or the physician assistant or the actual doctor, and they've come up with an initial diagnosis, and they need to validate it with some equipment. And it could be that a technologist or technician brings in a portable medical imaging device, and it has some other things with it, including like a barcode scanner, so that you can gather the metadata about the patient for the image that we're going to capture here in a minute. And you can see that this is the beginning of the data pipeline. And if you keep track of the boxes down at the bottom that are gray and the color coding, you'll see that, again, this is the data pipeline that's beginning. We're starting to gather metadata. We're going to bundle that together with the imaging and things like that later on. And there could be a laptop or something that's on that portable device that makes it easy for the technician to interface with all of these things, gather these data, and also do preliminary validation of making sure they did what's needed. Okay, so let's go on to the next step. Okay, so next step, imagine that now they're going to use that medical imaging device, which could be an X-ray, and they trigger that from their laptop using a control function capability of an edge device to say, please go take that image for me. And of course, they remind the patient just to lay still and whatnot. But that's another one of the flows within an edge ecosystem. That image is now captured, or at least being taken. And we'll go on to the next step. Okay, let's move on. Here is the beginning of the data ingestion, the actual image itself, okay? And as you'll notice from the X-ray device, it goes to what's probably a single board computer, and it might have a GPU or something associated with it. And what it does is it ingests that data and it cleanses it to make sure that it's the right size, the right contrast, there's information about, did you put the tag on it to show which is the right or the left side, things like that. And then it can actually run a model, a machine learning model that could be based on Keras or TensorFlow or Kubeflow, and do something for you to give you even a further validation. And beyond that, then it can display it back to your laptop for that technician to validate, okay, this step of the process is complete and done, and I can move on to the next one. So in this context, that single board computer could be running something like SLE Micro and even K3S, okay, because that's where the model's landing, that's where it's doing the image inferencing, the categorization, the segmentation, and all that. And let's move on. Okay, so let's watch a real live emulation of what happens. Notice the image in the upper right-hand corner. This would be what the technician sees on their laptop. They go through the classify thing, and voila. It comes back that quickly and kind of matches, hopefully, the diagnosis. And again, it validates what the technician has done so that they can wrap up and move on to the next patient. Okay, so now let's move on. Let's say the technician now transports that portable medical imaging device out of the room. And oh, by the way, now it can connect to the hospital Wi-Fi or whatever connections it has. And I can transfer that data, that image, the metadata from the scanner. All of those things can be transferred to what is probably like a near edge kind of cluster. This could be like, and I often comment on this and call it the closet computing cluster, right? It could be centralized within the hospital or within the doctor's office or within the facility, and things go there, and then the data can be can be sent to the PACS imaging or the PACS data system and stuff like that. But even more importantly, in this scenario, what also happens when that transfer does happen is the radiologist gets notified that, hey, this just came in, please take a look at this, right? And so the radiologist can connect from their desktop system if they're in the office or from their phone or whatever, and connect in and see the data. And they want to look at the symptoms that were recorded, the diagnosis, and now the medical image to kind of collaborate and confirm that that might be the issue. So that's what they would do as their next step. Okay, so again, once they've visually confirmed it by looking at the raw image that came in, the radiologist may go, okay, let me run the models against it. Let me do the classification. Let me check and make sure that what I'm seeing is the right thing. Okay, so they just signal and pull up basically the same kind of user interface that the technician had, potentially with more model clicks and classifications and segmentations, and they just want to go through and validate it. Okay, so while the radiologist now has visually confirmed it, looking through their view of the raw image, they fire up the model and do the segmentation. And you can see that they just click on that. And what happens is it does the translation of the image, and it also does the color coding and everything. And the radiologist then goes, yep, that confirms what I see and the things that I see. Yes, that highlights things correctly. Awesome. So they actually can confirm what the machine learning model did and tag it as such so that later classification runs and whatnot can utilize that for regression testing and things like that to make sure that we always do that one as well as we did this time. Okay, so now as you think about it, we've done two different tiers of the edge computing with the far edge, the portable medical imaging device, the closet computing cluster at the near edge. But that data now and the verification and the validation can also go now to the core or the cloud clusters, right? So that data can go up and it could be normalized and patient specificity could be taken out because it could go to a research or a university or something that's trying to do the model creation and whatnot. And again, it could be in the public cloud, it could be in the core data center for a hospital or an organization. So you can see how the data pipeline, that batch migration happens, the model then can run against that and whatnot. And the data scientists can say, cool, more data and more information and more tagging. Let's go ahead and test a newer model that we've been working on. And then further, what can happen too is the data scientists can generate the new models or auxiliary models. So remember, we looked at this from like a pneumonia perspective, but the same kind of a model for like COVID could be done and see if that's a joint condition or a cause of that condition or whatever. And then also, a tumor rendering model could be running as well to say, oh, and we see this as well, right? So that data pipeline that gave me the information that we need as a data scientist to create a model keeps growing and growing and growing. And we keep generating things and doing the regression testing to make sure that we don't undo something we did, but we get better overall. And at that point, now we can propagate that model back to that near edge, the closet computing cluster, which can also propagate that back to the far edge, that medical single board computer device that's hanging on the edge of the medical imaging system. So just to give you an example of how that is done, we'll go to the next slide. So as an example, what you might see here on the left-hand side of that thing that's flying by is basically the data scientists are just running a Jupyter notebook with more data now and more labeling and stuff like that, and coming up with better answers. And that's why they would propagate the model back to the near edge, the far edge. And if it's not working as well, then they revise the model and do that over again until they get better and better and better. So at the end of this, the benefactor is the patient. That testing happened, that validation happened, the treatment happened, they start to feel better. They have benefited from this edge ecosystem that's three-tiered that took into account all of those folks and all of those flows of control functions, of data pipeline, of model flows to benefit from this. And this is a classic thing of these real-time analytics can be run. And this environment was set up in my home lab using publicly available machine learning model and normalized data sets to do this. So these were really done live. So I hope that was really useful. And I hope you're interested in that, and that perks it in. And again, this is an opportunity that we're working on collaboratively with single board computing platform providers, hardware providers that provide things like in that near edge cluster, service providers, system integrators, because we got to work with medical imaging devices. We got to do, the validations and things like that. All of this stuff is an ecosystem that spans all of these areas. But at the end of the day, we're doing workloads across multiple environments in a really easy way to do that real-time kind of analytic for wherever the data was, wherever the data is, and whatever we think the answer should be, and also validating with people that are subject matter experts in each one of these contexts. So with that, let's talk about a little bit of a summary and takeaways for you. So if you were to look at the SUSE portfolio and where we played in this context, again, things deployed at the edge or a branch or the closet computing or wherever, they leverage things like SLE Micro and SUSE Manager and K3S and Rancher Server, so that now across all of that three tiers, workloads can be generated, managed, deployed, which are the models. And likewise, the data, because the containers can do the data pipeline piecing of ingesting, cleansing, doing contrast checks, things like that. All of these things can be done, right? So this is just how all three of those layers that are in this diagram kind of map into how in those three layers of the edge space, this can be accomplished. So with that, thank you again for attending, and thank you, Brian, for helping with the presentation and whatnot. Feel free to look on these things. And again, I would encourage you to reach out to the SUSECON agenda. Go find presentations on some of the things that were mentioned here. But this is how pieces get put together to create a very effective, efficient, and useful edge ecosystem to do the analytics at wherever the data is. Thank you again. Take care.